Hi, we're in Chapter 1, Section 2, Adding and Subtracting Whole Numbers. This is the third video in that section, and this is all about subtraction. Okay, so there are some basic properties of subtraction that I want to go through, and then I'm going to show you some ways to think about some of the details in borrowing subtraction, and then we'll jump in and we'll do some larger subtraction problems and a word problem. So, properties of subtraction in terms of cookies, because I'm hungry. Okay, if I had 6 cookies and I ate them all, then I have no cookies left. So any number minus itself is 0. On the other side, if I had a whole lot of cookies, 32 cookies, and I didn't eat any of them, then I still have 32 cookies. So any number minus 0 is that number itself. It does not change because you didn't eat cookies. Okay. I'm going to talk about subtracting 9. The reason why I want to bring that up is because almost every time in a large subtraction problem, when you subtract 9, you have to work with a borrowing. It turns out to be borrowing almost every time. And there's a little, there's a way of thinking about it that makes it easier to get the answer right. So there is one situation when we subtract 9 where we don't have borrowing, and that is when we subtract 9 from 9, 9 from 9 minus 9 is 0, I don't have to borrow, and so that 39 minus 9 is 30. However, when we look at this problem here, 35 minus 9, and I try to take 9 from 5 and I can't do it. And that's going to be the case for all of the digits other than this situation. I can't do it, so I'm going to borrow 1 from the 3. So I'm going to, the 3 gets reduced to a 2, that's in the tens place value. And then I bring that over and the 5 turns into a 15. So I want to talk about that borrowing subtraction problem, okay? I want to talk about 15 minus 9. 15 minus 9 is not the same as, but is close to 15 minus 10. All right, so I hope you don't mind. I'm going to talk about cookies again. If I had 15 cookies and I took away 10, that's pretty easy, right? So you end up with 5. But I'm over here, and I didn't eat all 10. I only had, I didn't eat 10 cookies. I had 9 cookies. So I should have 1 more cookie left. So notice that what happened here was 15 minus 9 is 6. The answer is to increase the ones place by 1. So 15 minus 9 is 6. Over here, we're going to say 15 minus 9 is 6 and bring down the 2. I'm going to show you one more of these problems so you can kind of see how it generalizes. So 83 minus 9. I cannot take 9 from 3, so I am going to borrow 1 from the 8, and the 8 turns into a 7, and that comes over here, and the 3 becomes a 13. So my subtraction problem, my borrowing subtraction problem is 13 minus 9. The answer is going to be 4. So I see that the digit above the 9 is a 3. And so the answer just is to increase that digit by 1. All right, 13 minus 9 is 4. You can do this here if you like. Sometimes I actually, even though I do math all the time, I still have to write my little subtraction problems on my borrowing subtraction on the side just so I get them right. The 13 minus 9 is 4, and you bring the 7 down. All right, good. So every time you subtract from 9, unless you're subtracting 9 from 9, you're going to do a borrowing action and then increase the answer is the ones digit increased by 1. Okay, so hopefully that helps. All right, there's a couple more situations which we can group together in our mind and have similar ways of thinking about things. So I want to look at this problem here. 86 minus 7. Okay, 86 minus 7. I am going to have to borrow because I can't take 7 from 6. But what I want you to notice that what we're talking about here is that the 7 and the 6 are next door neighbors, okay? The 7 is one more than the 6. They live next to each other. So every time you're doing a subtraction problem and you're subtracting next door neighbors, then this is what's going to happen, okay? So we have 86 minus 7, 7 minus 6, you can't do it, so let's borrow. And we end up with the borrowing subtraction problem of 16 minus 7. All right, so 16 minus 7 is similar to 16 minus 6, which would give me a 10, but I've taken one more away. I've eaten one more of those cookies. So 16 minus 7 is going to be a 9. So anytime I'm subtracting next door neighbors in a borrowing subtraction problem, my answer is going to be 9. So because it's the one less than if I were subtracting the digit itself. Okay. So here we are, back to our original problem, 16 minus 7, 6 and 7 are next door neighbors. The answer is 9, and we're going to bring the 7 down. Okay, so I have another next door neighbor problem here, and let's check it out. So 43 minus 4, I cannot take 4 from 3, but I'm going to borrow. Okay. So the 4 becomes a 3 and the 1 comes over. So now I'm looking at this problem. 13 minus 4. The 4 and 3 are next door neighbors, so my answer is 9. So over here I bring down the 9. 13 minus 4 is 9, and I bring down the 3. Okay, so that's the next door neighbor situation. A lot of your borrowing subtraction problems, we're ticking them off. If your borrowing subtraction problem is subtracting a 9, we have one set of ways of thinking about it. I hate to call it a trick because really it's based in mathematics, right? So here's one subtracting 9 strategy, the next door neighbor strategy, and the final strategy I want to bring is the almost next door neighbor strategy, okay? And we're going to look at this problem here, 24 minus 6. Okay, so we're gonna borrow 1 from the tens unit, and we end up with the borrowing subtraction problem, 14 minus 6. 14 minus 6. You know, it's a lot like 14 minus 5 would be 9, according to our next door neighbor problem, right? So you have 14 cookies, you eat 5, you got 9 left. What if you didn't eat all 5? What if, what if you ate 1 more? What if you ate 6? Almost next door neighbors, 4 and 6 are not next door neighbors, they're almost next door neighbors because you ate an extra cookie, now you only have 8 left. So when you have almost next door neighbors, the answer is 8, okay? So here we go, 14 minus 6 is 8. In this problem, we had 24 minus 6, we're going to borrow 1. 14 minus 6 is 8, bring down the 1. Let me show you this example here. We have 85 minus 7, 5, we're going to borrow. And so we're looking at 15 minus 7. 5 and 7 are almost next door neighbors, the answer is 8. And then we bring down the 7. Okay. All right. So that's all the setup that I wanted to share. It really comes down to the basic properties of subtraction, a strategy for subtracting 9s. 15 minus 9 is 6. 13 minus 9 is 4. So it's always increase that ones digit by 1. And then 2 more strategies. Next door neighbors have an answer of 9. and almost next door neighbors have an answer of 8. Okay, so I'm gonna give us a break and come back and we'll do a video where we use all these strategies together to do some subtraction work and that word problem. And then we'll be wrapping up section 1.2.